Hello, my super STEAM scholars. Hold on. Now, something is wrong here. I am looking for something. Where is that? Where is that switch? It is so dark in here. I need some lights. Hi, guys. I can see you now. I hope you enjoyed learning about sound and engineering those projects. I sure did. Today, we are going to learn about another form of energy called light. First, let's go over the design process because this is something we as engineers and scientists will use every time we meet to do our projects. So, with any project, we are going to do A, ask, what is the problem or what am I trying to create or solve? B, investigate. How can I solve or create? And C, collect. What information or data do I need? D, develop. We are going to think of a plan on how to do this project. E, evaluate. What works? What doesn't work? And what can I do to make it better? And then F, fine-tune. I will try again until my designs are where I want them to be. Now, let's jump right into today's lesson. Take some time, pause the video, and think about light. What is light? How do you use light in your everyday life? And what can light be used for? Very good. I really like your ideas and thought processes. Light is a form of energy that makes vision possible. All light has to come from a source. Sources like the sun, a light bulb, a flashlight, and a candle. And just like sound, light travels in waves. Light waves are also known as electromagnetic waves. Let's say electromagnetic waves together. 1, 2, 3. Electromagnetic waves. Very good. Electromagnetic waves are forms of moving energy that help us see color. How cool! Did you know that light can only travel in a straight line? Well, don't take my word for it. Let's test it out with some objects we may already have in our home and in our classroom. You will need a flashlight, your clear bucket from the last unit, a mason jar, and a book or piece of construction paper. Let's first try our mason jar. You'll want to make sure you're really careful with this because we will use it in one of our next projects. So, take your mason jar, unscrew the top, and turn on your flashlight. You can shine the flashlight on the top or on the side of your mason jar. Tell me, what did you notice? And if you put your hand on the opposite end of the jar, can you see the light on your hand? Why do you think this happened? This is what we call transparent. A transparent object lets all light pass through it. Pause this video and discuss with your class about other transparent objects you can think of. I think of clear plastic wrap, glasses, or a window. Now, let's try our plastic container from our last project. Take your flashlight, do the same thing, and as you can see, wherever you point the light source, that's where the light travels. That is because light travels in a straight line. So what did you notice about the light this time? Take a little time to pause and discuss. Hopefully you notice while pointing your light source, only some light is able to pass through. This is what we call translucent. A translucent object only allows for some light to pass through. In fact, translucent objects cause light to bounce off the object and scatter. Other translucent objects are sunglasses, wax paper, or a stained glass window. Can you think of others? You can talk about that with your class later. Get out your last object, your book or piece of construction paper, and let's test it out as we have done before. What did you notice? Did you notice that all you see is the light reflecting back at you? Reflection is the return of light from a surface. Opaque objects don't allow any light to pass through them. In fact, it blocks the light. And anything that blocks light creates... You got it! It creates a shadow. A shadow is the darker shape made when something blocks light. You must have a source of light in order to have shadows. Did you know a ray is a line of light that beams out from something bright, like a flashlight? What other things can you think of that have rays? Discuss with your class now, and push play when your discussion is over. At this time, your teacher is going to read you a book called Lights, Shadows, Mirrors, and Rainbows. It is one of my favorites because it helps us understand how lights, shadows, and so much more work. When we come back, we will review and I will give you your challenge for the day. I'll give you a hint. Come closer. Come on. It's I Spy with my little eye. That's all I can give you for now. Pay close attention to your story. There will be some questions at the end. See you soon. Questions. What fun facts did you remember from the story? In the story, they talked about how sometimes your shadow can be in front of you and sometimes your shadow can be behind you. Why do you think that happens? How? Think about this question throughout the Me and My Shadow unit as we continue learning. All right, let's recap. Light is a form of energy that makes vision possible. All light has to come from a source. Sources like the sun, a light bulb, a flashlight, and a candle. Electromagnetic waves are forms of moving energy that help us see color. And the three forms that light can and cannot pass through are transparent, which lets all light through. Translucent, which lets some of the light through, and opaque objects, which blocks light and creates a shadow. Reflection is the return of light from a surface. A ray is a line of light that beams out from something bright. And a shadow is the dark shape made when something blocks light. You must have a source of light in order to have shadows. So, I hope you learned about light, shadows, and what objects light can and cannot pass through. Your challenge for today is to have an I Spy challenge with your class. How many objects can you spy that are transparent, translucent, and opaque? And once spied, can you tell us what makes that object transparent, translucent, and opaque? Remember that we learned that transparent objects let all light through. Translucent objects let some light through. And opaque objects don't allow any light through and blocks light, creating a shadow. What do transparent objects have in common that make them transparent? What do translucent objects have in common that make them translucent? And what do most opaque objects have in common that make them opaque? Lastly, what makes a shadow? And have you thought about what STEAM career you're interested in yet? Maybe you'll enjoy being a photographer, an interior designer, a lighting engineer, optometrist, animation designer, an astronomer, or an illustrator or an artist. Whatever you choose, you will be great at. Be great, my STEAM scholars. Until next time, bye-bye.